Next, we are defining the screen width and height as constants. They're constants because they don't change, and we're using constants here so that we can, if we want to, change the width and height of our program, of our game, and those changes will be reflected throughout the code. You'll see we use those constants throughout the code whenever we need to know the screen width or the screen height. And then we are going straight into defining the player class. Now, because we've studied object-oriented programming, you'll be able to tell here that the player class is based on pygame.sprite.sprite class. So it's the player object or the player class that we're creating is based on the Sprite class in Pygame. So it inherits a huge amount of things, methods and properties from the Sprite class and abilities. So we are calling the super initialization of the Sprite class, and we are providing an image. Okay, so I've got a folder here called Pygame images and jet.png. You will need to change this to reflect the file name for whatever image you provide for your game when you run this code. Also, self.surface, you can see self.surface, the visible part of the sprite. So this is the image I'm using, and set color key actually defines a color in the image that is to be transparent. And this is where we're using RLE accelerate, that constant that I just mentioned to you. But I've got a tuple with 3 numbers here. You can recognize that is white. And what that means is, in my original image, I have jet, which looks like this. Now, if you can read in the upper right-hand corner of this screen, it says 62 by 25 PNG. So it's a PNG file, or ping. It is 62 pixels across and 25 high. That is tiny. Okay, this is magnified several times so that you can see the pixels, but this is a very simple little pixelated drawing of a jet. It's very, very small because relative to the screen, right, if it's 800 by 600, it's got to have room to move around. If my jet is 100 pixels wide, it's going to take up the whole screen. It's going to be impossible to dodge all the little missiles and that sort of thing. So you want all of this is a consideration as you're building your game. What do you want to do? What is it? What should it look like? How big should things be? I would suggest starting on the small side. But this one is a non-transparent ping file. If it was transparent, I wouldn't have to set the color key. But what I can do is, if it's non-transparent, I can choose a color, a single color in that image, to be transparent, which is what I'm doing here with set color key. So all that does is say all of the white pixels in this image should be transparent. And then finally, you can see here, self.rect. So the rectangle for that sprite is going to be based on the surface. And you can, if you read this, you can kind of see that. Self.rect equals self.surface.getRectangle. So there's a method that belongs to the surface object inside that player class that allows me to get the rectangle from the surface. So I'm using that image, the image size, as the basis for that rectangle. And that works well because the image is just slightly larger than the actual jet. If I wanted to make it a little more accurate, I could shave some off the top here, but I'm not too worried about it. It's good enough. That's a very small amount of space. Next, okay, so we've defined the player class, what it looks like, how big the sprite is. Next, I'm defining a method in the player class called update. Every sprite that you want to move on your screen or to detect a collision should have a method called update. And the reason for that is because it allows us to basically go through all of the sprites and just call update on each one. So this is what it's supposed to do each time the screen updates. So each time the screen updates, this sprite is going to check, are any of these keys being pressed? If they are, we're going to move accordingly. So if key press up, then self.rectangle.move, move in place. I'm moving 0 left and right, and I'm moving -5 on the vertical axis, which moves it up 5 pixels. Okay, you can see it'll move down 5 pixels, left 5 pixels, and to the right 5 pixels. Now, if I want my plane to move faster, all I have to do is increase this number from 5 to 7 to 10 or whatever. If I want my plane to move slower, I can move it slower by reducing this number. I can dynamically change this number based on all kinds of things, like the score or how many missiles are on screen or whatever I want to do. So I can tweak the difficulty that way. So in update, the first thing we're going to do is check and see if things are moving. The next thing we're going to do is, and we're still inside update here, we are checking to see if the player is at the edge of the screen. So if the left-hand side of the rectangle, it's pretty logical if you think about it. So left-hand side of the rectangle is less than 0, which means, is it hitting the left-hand edge of the screen, right, with the left side of the sprite? Then we set the left to 0, meaning it's not going any further than, you can't go into the negatives. On Pygame actually keeps track of sprites that are outside the visible screen area. So if I didn't have this, I could go an infinite amount off the screen that way, or in any direction. So the right-hand side of the rectangle, screen width. So there we go. There's that screen width constants again. So if I change that in one place, then this changes. Okay, and we have top is 0, and the bottom is the screen height. But those are the limits. So when I move, I'll get 1 sec. So when I move, every time the player class updates, I check the movement, and then I make sure it's not leaving the screen. And that is the update for the player class. In fact, that's the whole player class, is the airplane, what it looks like, how much space it takes up, and then each update, how it moves. Question?
So for the left, right, top, bottom, how come like the left and the top have 0, but the other two have screen width?
Because the screen width, whatever the screen width we know is 800, right? So I set that equal to 800 at the beginning of the program. So I'm saying if the screen right is bigger than 800, see, the left-hand side of the screen is always going to be at coordinate 0. The top of the screen is always coordinate 0 on the vertical axis. These change based on the size of the game screen. So it dynamically changes these numbers if I change the height and width of the game. Mm-hmm. So the class for player just has that very simple update. Next,